Welcome to Sparrow's Innovation. I am Arun Balaji. This is second video of Arduino tutorial. We are going to see about digital outputs in Arduino. In previous video I already explained what are the digital inputs and outputs in Arduino boards. Here in this video we are going to see only digital outputs, and also we are going to see how to configure a onboard LED. Every Arduino board will have a single LED which is connected to a digital pin. We are going to learn how to program that LED, that inbuilt LED, by using Arduino software coding. These are the two Arduino boards we learned about in the previous videos. This is Arduino Uno. You can see the name as Arduino Uno here. This is Arduino Uno, and this one is Arduino Nano. You can see the size between these two, Arduino Uno and Arduino Nano. Arduino Nano is much more compact than Arduino Uno, but there is not much difference between Arduino Uno and Arduino Nano. Same microcontroller is there in the Arduino Uno and Arduino Nano. Only thing is Arduino Nano is compact compared to Arduino Uno. But Arduino Uno having more voltage protection devices than Arduino Nano, so that if you power more power supply to this Arduino battery unit and the USB is also powered on, then it will protect your microcontroller present in this Arduino board from this voltage hike. And this microcontroller, that means the Arduino Uno having a microcontroller called ADMEGA 328P. You can see it's clearly here, ADMEGA 328P. This is the AVR family based microcontroller. This ADMEGA 328P is used in Arduino Uno and Arduino Nano. This I already explained in the video 1, right? And you can see here in the right side, you can see the pin numbers as mentioned as 0, 1, 2, 3 up to 30. These pin numbers are used as digital input and digital outputs. The pin number 0 and 1 is used for serial communication for receiver and transmitter. All the other pins you can use for digital input as well as digital output. And you can also see the pin numbers 3, 5, 6, 9, 10 and 11 is mentioned with the complement symbol. These 6 pin numbers can be used for PWM operations. That means the PWM is nothing but the analog output operation by using this Arduino board. In the left side you can see the pin number mentioned as A0 to A5. These are analog input pins. Defaultly this is used for analog input pin. I already explained in the previous video that these pins are used to read the sensor values and convert that into digital values, right? And these pins can also use for digital input and digital output pins by using program configuration. And here you can see the voltage pins are here, 5 volt and 3.3 volt are here. So when you power this board by using a battery or by using a USB cable, the voltage regulator will convert that voltage to 5 volt and 3.3 volt. So you can use it anywhere here for any other connecting any other hardwares to this Arduino board. And you will be having this V-in pin. You can connect a battery directly to this V-in pin, and the battery voltage should be not more than 12 volt DC. And you can also connect the battery by using this DC jack. Here also the voltage range is up to 9 to 12 volt DC. And you can also power by using this USB port, and this is a reset switch. That's all you need to know about this Arduino hardware. To know about Arduino software, you have to connect your Arduino board to your computer by using a USB cable. So first we are going to connect the USB cable to this Arduino board. So when you connect this, you can see it's powered on. There is a LED light which shows the power is on or not. Okay, this is the power on LED, and you will be also having more LEDs here. So this is for receiver and transmitter. You can see RX and TX LEDs is here, and this one LED mentioned as L. This is the onboard LED. We are going to program this onboard LED, and we are going to make a on and off example by using this onboard LED. This onboard LED is connected to pin number 13, digital pin 13 in Arduino Uno, Nano and Mega. And this 13th pin you are going to control by using a software to make this LED on and off. I connected my Arduino Uno board to my computer by using the USB cable. Now I open my Arduino software. So before going to the program, we have to do one important thing first when we connected any Arduino board to your computer. First we have to select the board by clicking the tools here in the software and go to board and check for Arduino Uno. So see, these are the different model names available in the market for Arduino. So whatever board you are using, you have to select this from the board here. Okay, so for example, if I am using Arduino Uno, then I have to select Arduino Uno. If I am using Arduino Nano, then I have to select the Arduino Nano here. Or else if I am using Arduino Mega, then I have to select this Arduino Mega here. So now I am using Arduino Uno only, so I am going to select this Arduino Uno here. Okay, now I selected my board as Arduino Uno. Next thing I have to do is I have to select the communication port. Okay, so we connected our Arduino board using a USB cable here, right? So this USB cable will be connected to any one USB port of your computer. So we have to check which port is connected to your Arduino board. For selecting that, you have to go to tools again and click check for port. See, it's already connected to COM port 4. Okay, if it's not shows here correctly, then go to click this port here and check for the COM port here. So I am using Arduino Uno, so the COM port will be highlighted with the Arduino Uno in the bracket. Okay, it may be COM4 or COM5 or COM6, anything it may be, but it should be mentioned as a Arduino Uno in bracket. So I have to select that COM port to enable my computer to program with my Arduino board. So I'm selecting this COM port here. So now my board is selected, my COM port is also selected. So now my Arduino board is ready to upload my program, right? So I already explained what is the program of void setup and while loop here. So here first we have to check the program is correct or not. So first I am going to verify this program. This is a blank program, so there is no issue in verifying this program. First I am clicking this verify button to verify whether there is any error in my program. So when I click the verify, you can see here compiling sketch, and you can see a green color notification here. So after the green is completed, it will show done compiling. So we will wait for that. See here, now it's done compiling. There is no error here. I'm just verify the button, verify only, so it shows no error here. So for example, if I make a wrongly we make an error like this or xd without any semicolon here, and then I am trying to verify my program, it will ask for save the program, because I'm just editing one small thing. So it's asked for save my program. You can save it or you can give escape to unsave it. So I'm just giving a example 1 to save this. So now it's saved, and you can see compiling sketch, and now it shows there is a error in my program. It shows with the orange color notification. See, ed was not declared in this scope. So now this is the error ed which is shown without no semicolon. So now I want to remove this error, and also you can scroll here to check for more errors in your program. Here it's only one error, so it shows here, and we have to remove this and then try verify again. So after verifying, you can see it's compiling sketch and done compiling. Now there is no error. So I have completed my verification of my program here. Next thing we have to do is we have to upload the program. This is a blank program. Anyhow, we can upload this program to your Arduino board. So to upload your program, you have to click this icon, upload. So after clicking this icon upload, the program will be converted to hex file, and that hex file code will be uploaded to the microcontroller present inside the Arduino board. So I'm just clicking upload button here, and you can see upload sketch. So now it shows done uploading. So the program is now uploaded to my microcontroller present in this Arduino board. So that's all we need to know about how to upload the program, and how to select the board, and how to select the port. And this is a basic thing we have to do when you connect your Arduino board to your computer. So when I uploading the blank program, you can see the LEDs of receiver and transmitter. This shows there is a data receiving in the Arduino board. So now the program is uploaded, done compiling. So you can see this receiver and transmitter, it should get blink because the data is transmitted through USB cable. So it will shows there is a data is getting uploaded. Okay, so now the program is uploaded. So this is a simple blank program. So there will be no working in this program. I am just explaining how to upload the program in Arduino board. Now we see about the onboard LED in the Arduino. Before using any digital input and output pin of Arduino as an input or output, you have to configure that pin as either input or as output. For configuring any digital pin as input or output, we have to use the function called pinMode. This is your Arduino's function. So by using this Arduino's pinMode function, you can configure any digital input output pin as input or output. So this is the syntax of pinMode function. Your pinMode, here M is capital letter in pinMode, because the function names is case sensitive in C programming. So you have to use the exact name of the function name. So pinMode, pin is small letter and M is capital letter in the pinboard. In this syntax, pinMode, comma, your pin number. Pin number, you can use any digital pin number from 0 to 13 if you are using with any LED or any other input output devices. And the state is either input or output. This is a simple example for making any pin as output. Here in this example we are using a digital pin 12 as output. So pin mode 12 comma output, so that in this program will configure your pin number 12 as output, digital output. Okay, the same way we are talking about LED built-in, because we are going to program an onboard LED. In Arduino, the default keyword for onboard LED is LED built-in. Okay, so that means LED underscore built-in. So in Arduino Uno and Nano and Mega, the pin number 13 is used for LED built-in. That is, the onboard LED is connected to digital pin number 13 of Arduino Uno, Nano and Mega. So we are going to program that pin number 13 to perform the onboard LED sequence. So pin mode LED built-in comma output will configure the pin number 13 to make your LED on and off. This is to configure your pin as input as well as output only. This pin mode is a single time initialization command. That means if you initialize this command in the beginning of your program, the entire program, the pin number 13 will act as a output. That is, your LED built-in pin will act as a output. So we have to use this inside void setup. We no need to use inside void loop because we need to initialize only once. So use in the void setup. So in the Arduino program, in the void setup, we are going to use the pin mode. You no need to use this. This is a just single command, default command. You can delete that. So in void setup, you have to use pin mode. See here, M should be capital letter, and you can see the color is changed to red when you given the name correctly, the function name correctly. If you mention the function name correctly, then it will shows the color. It will change the color to red. So pin mode LED underscore built-in. This will stands for the pin number 13. This is a keyword for pin number 13. So now pin mode LED built-in comma output, because we are going to configure this pin as output, because LED is an output device. So now you can see this single line program will configure your pin number 13, that is your LED built-in pin, as output. Next we have to change the output value. After configuring the output, we have to assign some value to the output pin. For assigning a value to the output pin, we have to use the function called digitalWrite. In this digitalWrite, we have to use the digitalWrite your pin number comma the state, that means your output state. So digitalWrite here, instead of pin you can use any digital input output pin numbers. So for example, I am using digitalWrite 12 comma high. That means it will stands for your pin number 12 as active high, that means logical high. That means if you are connecting any LED to the pin number 12, the LED will become on when you connect this digitalWrite 12 comma high. If you want to make that off, you have to use digitalWrite 12 comma low. Low will give a logical low at the output. So this is the digitalWrite function. Since we are learning about LED built-in, we can use like this digitalWrite LED built-in comma low, which will make your onboard LED as low. Or else you can use as digitalWrite LED built-in comma high, which will make your onboard LED as high. So in the program, in the void loop, we have to use digitalWrite LED built-in comma high, which will make your LED high. So after completing the program, you have to verify the program. To verify the program, click on verify icon here. So now you can see done compiling. So there is no error in the program. Then I can upload the program. So whenever I click the upload button, the program will convert it to a hex file, and that hex file will be uploaded to my microcontroller in the Arduino board. So I am going to upload my program. So now the program is done uploaded. So that means your program is now uploaded to your Arduino board. So you can verify that program in the Arduino board. So now you can see the onboard LED is off. We are uploading the program for onboard LED to make is on. So you can see this receiver and transmitter is getting blinking. Now when the program is done uploading, so you can see this onboard LED is on now. So as per our program, this onboard LED is on now. Right? Now we will change this to off condition by using your software program. Now to make your LED off, you can change this height to low, and then upload your program again. So small changes you should be upload the program again, so that only your changed program will be uploaded to your microcontroller. So now it's done uploading. Now you can check your Arduino board for your built-in LED off. Now I uploaded for OnBoard LED off. You can see now the program is getting uploaded. So done uploading, the LED is getting off. So this is how I am programming my onboard LED on and off by using my software. Our next video is Arduino tutorial 3. If you like this video, please subscribe and share. Thank you.